Hi, welcome to section 7.4 on doubling angles. So last time the angles were two different angles. Now we're just going to do the same angle twice. So the proofs for these are pretty straightforward. So I'm just going to show them to you. So we're just going to kind of run through them really quickly. These are nice to kind of see, but you don't necessarily need to like have them written down in your notes. I'm never going to ask you to prove them, but you'll need the idea of what this proof is doing. So it's up to you how much you want to write down. I don't think you need much of it. So rather than having two different angles, we're going to assume that the angles are exactly the same. So the angle is doubled. Well, what you end up getting is instead of these two things that we couldn't put together, you get these things that you can put together. So this is identical to that. So our sine double angle is just 2 times the sine of that angle times the cosine of that angle. For cosine double angle, you get, so cos, sine, sine. So it's like, well, it's cos and the angle and cosine the same angle. Well, cos and cos, that's just cosine squared. And sine, that's just sine squared. And then finally, tangent, again, it does a mixture of the two. In the numerator, you get a little taste of what sine double angle is. So you get 2. And then in the denominator, you get this 1 minus tangent squared, which you might recognize from our Pythagorean relationships. I believe that for Pythagorean, it's like 1 plus tangent squared. It's a secant squared. I can't remember off the top of my head. But cosine loves to play around with that Pythagorean relationship. So here's the one that we just proved. But if you swap this cosine out with a 1 minus sine squared, you can create this one as an alternative option. And they are alternative options. You could use this one or you could use this one, depending upon what you're working on and what would work best for that problem. And sometimes the first one's good, sometimes the second one's good, or you could even use the third one. So it doesn't matter which one you use. It's just use the one that works best for the problem that you're working on. And you can probably use any one you want, really. So these are our double angle identities. So let's try them out. Let's see how they go. So I've got 2 times the tangent of 150 degrees and 1 minus the tangent squared of 150 degrees. I want to figure out, okay, well, what's going on with this thing? Now I could figure out what the tangent of 150 degrees is. I know that the tangent of 150 degrees is the same as the tangent of 5 pi over 6. I'm doing that correctly in my head. So I could do the tangent of 5 pi over 6. Sure, no problem. But then I'd have to double it. And then I'd also have to square it and then subtract it from 1. Ugh, can't be bothered. This is the same as tangent double angle. So instead of doing all this nonsense, how about we just do what tangent double angle tells us to do? So it matches this. So instead of doing all this garbage, just double the angle and slap that in tangent. All right, sounds cool. So we get, so all that, we get, if I can write the tangent of 2 times 150 degrees. Ooh, that's much neater to deal with. Well, that's the tangent of 300 degrees. I don't know what the tangent of 300 degrees is, but I do know what the tangent of, what is it going to be? It's going to be pi over 3. So 5 pi over 3 is, if I convert that into a radian, so 300 degrees is the same as 5 pi over 3 radians. And I know what the tangent of 5 pi over 3 radians, it's going to be negative because that's in quadrant 4, and tangent of pi over 3 is the square root of 3, so it's just that. Done. Woohoo! It's great. Let's try another. When I look at this one, I say, oh, dang it. It's 7 pi over 8. I never learned my pi over 8s. I'm not going to bother learning that now. Unfortunately, this is not matching up right now. This one's got a sneaky trick to it. And it doesn't happen very often, but every once in a while I get little sneaky tricks, and I like to show you sneaky tricks. We got a sine, we got a cosine, we don't have the 2. The 2 is missing. Shoot. Why? Oh, can I just multiply this thing by 2? And then I'd be set. I'd be able to do sine double angle. It'd be so sweet. But I can't because there's no 2 there. Unless I put it there and get rid of it. If I multiply by 2 and divide by 2, I've really done nothing to the value of this expression. However, that numerator now is looking real good for being sine double angle. So this is now sine double angle, and then whatever value I get out of my sine double angle, I'll just divide it by 2 when I'm done. Hooray! So the numerator becomes the sine of 2 times that 7 pi over 8. And then we're still going to just remember, when we're done, we're going to divide that thing by 2. Okay. 2 times 7 pi over 8 is going to be 14 pi's over 8. So that's the sine of 7 pi over 4. And that's all over 2. Oh, yeah, I know what the sine of 7 pi over 4 is. It's negative square root of 2 over 2. Divided by that 2 still. That's my equal sign. So square root of 2 over 2 divided by 2 is going to be square root of 2 over 4. And we're done. We're done.